Hello, my name is Alex, and this is Kerbal Space Program, and today we're going on a mission. But we're not going to Eve. We are actually going to the asteroid Rock, which is in orbit around Eve. Or we would be going to the asteroid Rock, had someone not been a little excitable with the staging button. We're actually going nowhere. Forever. So the real mission today is to rescue Bill, Jeb, and Bob. Again. Alright, we have our mission. Now let's assemble our ship. Except our mission has grown to be something a bit more than just a simple go to Eve and rescue the crewmen. It's actually become quite a bit more complicated than that. After the events of Rock Expedition 1, Command decided that they didn't want to risk any more Kerbal lives to investigate just what's essentially a boring rocky asteroid. So they decided the safest way to continue this grand science expedition was to bring the asteroid Rock back to Kerbin. That is going to take an extreme amount of effort and incredible amounts of infrastructure, fuel, very many launches. So what we need is more than a rescue ship to start with. We actually need something with multi-mission capabilities. And what we have here is the beginnings of that ship. It's essentially just a truss segment with a whole pantheon of docking ports. We have a bow and stern Clampotron Senior. Those are going to be used for the heavy lifting, carrying fuel, crew habitation sections, the big heavy bits of hardware. We also have the small Clampotron Juniors basically strewn around the keel, and they're going to be carrying around various science equipment, probes, research hardware, basic small light things. Also, we see we're coming up on circularization here. Here we go. And you can see here very clearly that we have two pairs of regular Clampotrons on either side. That's going to be the mounting for the engine nacelles. So what we have here is a very modular format for a spaceship. We can change out the engines if we need to build something more efficient, more capable. We can add various amounts of fuel and other hardware to the front and back. And just anything we need, we can attach to this. And should be fairly straightforward. Because this section is just a bunch of trusses and docking ports, it's very light, so getting it into orbit is not that big of a deal. We're going to put it into a 100 by 100 operations orbit. If you see in the upper right hand corner, you have the relevant orbital data, apoapse, periapse, some other things that we don't really need at this moment, but are going to come into play later on. So we're just setting up for our final circularization burn for this segment. Just pointing towards the maneuver node. And here we go for the circularization. Okay, and there we go. That will be our operational orbit. 100 by 100 is a good low but not too low orbit. We still have plenty of room to maneuver beneath the actual operation zone. Okay, now that the truss segment is fully in orbit, we're going to deorbit the orbital injection stage. Okay, just point it retrograde and burn away all that fuel, and it'll safely crash into the surface of planet Kerbin. And there we go. Now, let's just get this set up for further operations. We're just going to orientate it normal. Okay. And there we go. Now the bow Clampotron Senior is pointed normal, the stern anti-normal. Now that we have that set up, we can start adding modules. First module we're going to add is the crew habitation section. So let's just bring that up here. The module itself is more than just a 3-man capsule. It's actually more of a spaceship in a capsule format. It has RCS, fuel, ASAS. It is a spaceship in and of itself. but it doesn't have the kind of delta V needed to take it to even back. So it's going to piggyback on the as yet unnamed carriage section. Okay, here we go. Just getting it up out of the atmosphere and into orbit. Nothing fancy going on here, just burning above and coming down for orbital injection. Also not a very heavy craft, but has a fair amount of fuel in it. In fact, we're actually not going to use this injection stage for the final circularization or even proper injection. It's more of an orbital ascent stage. The capsule itself is going to handle the final injection burn. More efficient that way, we have less debris left over in orbit. We actually have none, we just have the capsule. We like to be very, very clean here. Okay, and setting up for orbital insertion and rendezvous if we can. No, not in one orbit. Okay, coming around. It's going to take us a few orbits before we catch up with the carriage section. So, here we go. We can just circularize now. It's actually very squirrely because we have so much mass in such a tight form factor. So, very maneuverable, but very unmaneuverable as well, if you get my meaning. It can get out of hand really quickly. And it doesn't help that I think one of the sets of thrusters are out of alignment, so it tends to yaw around. So you gotta leave ASAS on for any extended operation. Now we've rendezvoused with the carriage element, and we can begin attaching this module to it. Okay, 500 meters away, we're going to burn off our relative velocity and just align ourselves toward it. Keeping the retrograde marker aligned with direction of the ship. Now let's point towards the actual carriage, if we can find it. There we go. And we're going to use our main thrusters for the actual rendezvous. Just because we have a fair amount of fuel, and we don't really need it for anything once we are docked with the carriage. Okay, lined up. Now let's just slam on the brakes, coming in really quickly, but we're okay. A little close there, but I guess it's most efficient. So let's just align this thing anti-normal. Well, the docking port on the bottom is going to be aligned anti-normal. Okay, here we are. Now we're just going to align it up with the docking port, set it as a target, and here we go. Fairly standard docking operation. Because the center of mass on the capsule doesn't deviate very much with loss of fuel, the sets of RCS it has, RCS thrusters, are very effective, and it doesn't wobble very much. Okay, basically lined up. Now, one thing we do need to do is we do need to align them on the yaw axis as well, just so that the RCS thrusters themselves are working with each other and not against. So what we're going to do is we're going to take the carriage and we're going to point it parallel with the horizon line. And then we're just going to do the same with the capsule and dock them together. Okay, drifted a little bit, but not a lot. Just bring it down and over. And okay, lined up. Now let's bring her in. And here we go. We have good duck. Okay, and we have the basics of our ship. We just need to launch the engine nacelles. But before we get that taken care of, let's just come around to the day side and take a good look at how we've progressed so far. And now we can work on putting the engine cells up. Now we're going to use the nuclear thrusters for the engines on the nacelles, just because this is a strictly orbit-to-orbit ship. It's not going to be doing any, if at all, atmospheric operations. So the nuclear thrusters will have the most efficiency there. And putting it up, we're just going to use a fairly straightforward asparagus booster concept. Okay, here we go. Beginning our pitch over. We're actually pitching over a little too aggressively. So we're probably going to have problems with atmospheric drag. Yeah, we are way too far down. But we have plenty of delta V, so it won't be that much of an issue. Okay, doing our injection. Yeah, we are far too low. And we are actually falling a bit now, so we'll just pitch up a little with the nuclear engine. And we're coming in a little bit above where we want to be, but in this instance, the atmospheric drag actually helps us out. It drops us down a little bit. Now we can just circularize from here. Okay, there we go. And we still have to catch up with the carriage element. This will be the starboard engine cell. It's got a few orbits to go before it catches up. Now let's put up the port nacelle. I'm going to learn from our mistakes on the starboard nacelle. We're just going to be a lot less aggressive with our gravity turn. And that blew up for some reason. We won't worry about it. Just keep going. Okay, coming up nicely. There goes that stage. And we're going to begin our gravity turn now, but we're not going to be as aggressive. We're going to try and chase the prograde marker instead of being centered with the prograde marker. Okay, here we go. And yeah, we're coming up much nicer this time. Okay. But we still have a lot of energy to go before we're at orbital velocity. And we're already well above the target orbit. So we're actually going to have to do a half slide, half injection burn. That way our apoapsis drops, but we still add considerable amounts of orbital energy. Okay, and if you look up in the upper right hand corner, you can watch that happen. See our apoapsis is coming down, but our periapsis is still coming up. Okay. And that section's out of fuel. We can be a bit more aggressive with this section because of its lower thrust to weight ratio. And, well, that's good enough. Okay, it looks like we have about 2 orbits before this section is going to be in a rendezvous window with the carriage element. That's a little hairy because it looked like it was about 3 orbits before the starboard nacelle was going to be in window for a rendezvous. Okay, and we're setting up the rendezvous maneuver. It's actually 1 orbit. Ooh. Okay, here we go. And there we are. We're set to rendezvous with the carriage. Here we are. Let's just cancel out our relative velocity. And what we're going to do is we're actually going to move that prograde marker up by, instead of burning at the direction of it, above it. And now we got to worry about the starboard nacelle as well. Port nacelle is coming into rendezvous more closely with the carriage element while this is going on, so this is very much a ticking clock here. Hopefully the port nacelle doesn't crash into the carriage. Okay, and that's set up to rendezvous. Now let's go back and dock with the port nacelle. We have to do this in one orbital period because the starboard nacelle is going to be set up to do the same thing. So we are on the clock here, and you can see the carriage element is jumping around. That's because of the use of time warp. Learned my lesson here. We're not going to use time warp for the remaining docking maneuvers. Okay, so let's just get headed towards the superstructure. Okay, 0.1 kilometers. We could probably be a bit more aggressive with the approach, especially since we're on the clock here. But I normally like to take my docking approaches and docking maneuvers rather slowly and carefully, just because it's kind of the way I do things. But we are coming in very nicely. Now let's just zero out our relative velocity. Okay, and while this is more or less stopped here, we're going to switch to the superstructure and align these side ports to normal and anti-normal, just to make the docking of the nacelle a lot more effective. Okay, and we could do the same thing for the nacelle itself. Okay, very squirrely too, but that'll be complementary when both are on the superstructure. It'll be a very maneuverable but hefty ship. Okay, and we're just going to line the docking ports up in the cardinal directions first. So as you can see by the targeting the nav ball down there, the target marker is roughly horizontal to our directional indicator. Then we can just come over. And then our docking ports should be aligned up, and we can finalize the alignment. Except that's not how the targeting indicator works. The targeting indicator works on the center of mass of the object and not on the position of the docking port. So we're actually going to have to eyeball it. So what we want to do here is get them roughly lined up and then turn around so that they're parallel to each other. Okay, taking this nice and slowly. Since the superstructure is made up of just some trusses, it's actually fairly easy to use it as a ruler and get very good alignment between the two sections. Okay, now we just gotta line up the docking ports, and we were checking on the starboard nacelle too, because that's going to be coming up for rendezvous and docking very shortly. Okay, just bring it over and bring it down a bit. It's roughly lined up. Get straight and just a little bit over. Okay, that should be good enough. Now let's come in for the docking. Now we actually have to get both these sets of docking ports set to dock at the same time, so they have to be perfectly aligned. If they don't, you'll have a situation where one docking port is fully docked and the other isn't, and you lose a lot of structural integrity that way. Okay, and now we have the starboard nacelle ready for approach. Just gotta find that retrograde marker. There it is. And cancel out our relative velocity. There we go. Now let's just burn towards the target. The good thing about the pairs of docking ports is it'll create a very strong structural linkage, so you won't see very much wobble when the engines are at full power. It should be the case where if one is in tension, the other is in compression, and so they would cancel each other out. That's the theory anyway. Hopefully it works out that way. We'll find out. Okay, now we're just coming up to the superstructure. Almost have ourselves a fully functioning and fully operational ship here. Just gotta get this last nacelle docked. We're actually coming right towards it. We need to be coming under it. So let's do that. And we're not going to make the same mistake last time where we align in the cardinal directions with the targeting indicator first. We're actually going to align parallel to it, parallel to the superstructure that is, first, and then worry about getting our docking ports positioned. Okay. Now let's just point our docking ports in the right direction first. We're actually fairly close to it to begin with, so this operation will be a lot more straightforward and less wasteful of RCS fuel than the docking of the port nacelle. Okay, roughly lined up. We can worry about fine alignment once we get closer to it. Have better indication of how off we are and how to fix it. Okay, let's just bring ourselves up. Okay, they're roughly aligned there. I'll straighten out a little bit better too. And they look fairly well aligned here. So we can start to come in with this docking port, or with this nacelle. Okay, we're a little bit out of alignment here, but that shouldn't be too much. They should both link up at the same time. And here we go. And what happened? Oh, I know what happened. That's what happens when you pay attention to just your eyeballs and not to the targeting indicator. If you look down at the nav ball, you can see that we are very far off. So what we need to do is we actually need to use the nav ball for horizontal alignment, and then eyeballs for vertical alignment. Okay, and we're much better in this position. See, we are aligned horizontally and aligned vertically. We can come in nice and slowly to get these two ship sections docked, and there we have it. All 4 docking ports are set up. We have ourselves a rescue ship. We're very nearly ready to go. On next week's episode, we'll launch up some additional fuel and hardware. Then, we'll make our departure for Eve. Until then, I'm Alex, and this has been Kerbal Space Program. Thank you very much for watching.